Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Today we are going to talk about the properties of centroid. The centroid is a point that in a triangle, three median are concurrent, and the concurrent point is called centroid. So, the property 1. Let G be centroid of triangle ABC. Line AG intersects BC on D. So let's just draw it here. A, B, C. And roughly say this is G, this is D. Then D is a midpoint of BC, of course, because AD is a median. Then AD squared equals 2, half of AB squared plus AC squared minus 1 quarter of BC squared. And AG to GD equals 2 to 1. So this should be a property that my audience are already familiar with, but in case that you have a doubt, so let's just calculate it, right? D, E, F. So we know that A, D, B, E, C, F are the median, and we want to prove that these three medians are concurrent, right? So we can just use Sylvers theorem, right? Use Sylvers theorem. We have that AF to FB times BD to DC times CE to EA. And we know that AD, BE, CF are median. So AF equals to BF, BD equals to DC, CE equals to AE. So this one equals to 1. Then we use the converse of the Sylvers theorem. We know that these three lines are concurrent. We call the concurrent point as G. Then we can use the Mendeleev theorem that AF to FB times BC to DC times DG to GA, right? We use the Mendeleev theorem on the triangle ABD and the intersection line FGC, right? So we get AF to FB times BC to DC times DG to GA equals to 1, which means AF equals to FB, right? BC to DC, that is 2, which means DG to GA equals 2.5, right? So DG to GA equals 2, 1 to 2. And here we go. AG to GD equals 2, 2 to 1. That's the same. And for AD squared equals 2, this one, we actually proved it before in the Stewart theorem, right? And now let's just prove it again here. Actually, we can just prove it by write down the Stewart theorem here. A, B, C, P, right? So in triangle ABC, we know that P is a point on the BC, so AP squared equals 2 AB squared times PC to BC plus AC squared times BP to BC minus BC squared times PC to BC times BP to BC, right? That's Stewart theorem. So if P is a midpoint of BC, this is 1 by 2, this is 1 by 2, and this is 1 by 4, right? So that's this equation, okay? So let's see the next one, the property 2. let G be centroid of triangle ABC. Okay, we draw a triangle ABC here. And roughly say this would be the G. Okay, DE passes through G and is parallel to BC. And D intersects AB on D, AC on E. PF passes through G and is parallel to AC. Right, so P is on AB and F is on BC. KH is parallel with AB, right? And K is on AC, H is on BC. So we want to prove that DE to BC equals to FP to CA equals to KH to AB equals to 2 to 3. Okay, so we already know that G is a centroid, right? So we connect AG, and then we know this point is a midpoint. M is a midpoint of BC, right? M is a midpoint of BC. So because DE is in parallel with BC, that means DG to BM equals to AG to AM equals to 2 to 3, right? And GE to MC equals to AG to AM equals to 2 to 3. We know that BM equals to CM, right? BM equals to CM, which means DG plus GE to BM plus MC equals to DG to GBM equals to 2 to 3 equals to DE to BC. Right, similarly for FP to C and KH to AB, they are all 2 by 3, and the summation would be 2. That's obvious. Let's see the property 3. Let G be centroid of triangle ABC. P is any point in triangle ABC. Okay, let's just draw the figure first. A, B, C, D, E, F, G. Okay, G is a centroid of triangle ABC, and P is any point in triangle ABC. So let's assume maybe here would be easier. P, right? Okay. Then we want to find the relation of AP, BP, CP, and AG, BG, CG, and PG, right? Obviously, we have to use the Stewart theorem a lot in this one, right? So we want to prove that. Let me just write it down here. AP squared plus BP squared plus CP squared equals to AG squared plus BG squared plus CG squared plus 3PG squared. And we want to prove that GA squared plus GB squared plus GC squared equals to 1/3 of AB squared plus BC squared plus CA squared, right? Okay. So think about how can we get GP. We can get GP if we know BP and PE. How can we know PE? We can get PE squared from triangle PC, right? E is a midpoint of AC. So PE squared equals to half of AP squared plus CP squared, or maybe I should, yeah, AP squared plus CP squared minus quarter of AC squared, right? That's PE squared. And with knowing PE squared, we can calculate for PG squared. PG squared equals to BP squared times BP squared times GE to BE, which is 1, 2, 3, plus PE squared times BG to BE, that is 2, 2, 3, and minus BE squared times GE to BE and times BG to BE, that is 1, 2, 3 times 2, 2, 3. Right? And what is BE squared? BE squared equals to half of BA squared plus BC squared minus 1, 2, 4 AC squared. Right? That's a BE squared. So we replace the BE squared, PE squared into this equation. Then we got, let me write down here. Then we got PG squared equals to BP squared times 1, 2, 3 plus PE squared. That's all of this. So half of AP squared plus CP squared minus 1, 2, 4 AC squared. That's P squared, right? Times 2 by 3 minus BE squared, which is this part. That is 1, 2, 2. BA squared plus BC squared minus 1, 2, 4 AC squared and times. That's it. That's BE squared, right? Times 2 by 9. Now we extend this one. Expand this one. So we have, see, this is half, right? And times 2/3, that is 1/3. So there's no CP, AP, BP on other terms, right? So we directly got 1/3 of BP squared plus CP squared plus AP squared, right? And for this one, it's minus 126 AC squared, right? And minus, what about this one? That's 129 BA squared plus BC squared, right? And for this one, plus 1 by 18 AC squared, right? Equals to 1, 2, 3 BP squared plus CP squared plus AP squared minus C minus 126, that's 3 to 18 plus 1 to 18, that's minus 2 to 18, which is minus 1 to 9, right? So minus 1 to 9 AC squared plus BA squared plus BC squared, right? So we times 3 on both sides, we got 3PG squared plus 1, 2, 3 AC squared plus BA squared plus BC squared equals 2 BP squared plus CP squared plus AP squared, right? And look at these two equations. We want to prove that the summation of AP, BP, CP squared equals to 3PG squared plus this one, AG squared plus BG squared plus CG squared. But here we have 1/3 of AC squared plus BA squared plus BC squared, which is actually the second question, right? So we want to find the GA, GB, GC, square with AB, BC, CA, right? So let's look at here. For the BG square, let's just write BE square we already have, right? BE square. Right, B square is here. This is B square, right? B square is this one. So what about BG square? B square equals to 1 by 2 BA square plus BC square minus quarter of AC square, which means BG square equals to BG to BE square times BE square equals to BG to BE, that is 429, right, times BE square is this one, so 1 by 2 BA square plus BC square minus 124 AC square, right? So it equals to 2 to 18 BA square plus BC square minus 129. Wait, did I do something wrong? Here, it's 9, right? 2 to 9. 2 to 9 minus 129 AC square. Right, that is BG square. So look at here, BG square equals to 2 by 9 AB square plus BC square minus 1 by 9 AC square. So similarly, we can get AG square equals to 2 by 9 BA square plus AC square minus 1 by 9 BC square, right? And similarly, CG square should equals to 2 by 9 BC square plus AC square minus 1 by 9 AB square, right? We sum this together, so BG square plus AG square plus CG square equals 2. See, that's for each term it's 4 by 9 and minus 1 by 9, so that's 3 by 9, which is 1/3, right? So 1/3 of BA square plus AC square plus BC square, right? So look at here and here, we just prove it. And once this equation is valid, then we directly get these two to be equal, right? So this is valid and this is valid. We just prove that. Okay, property 3 is done. Let's check property 4. Property 4 is saying that let G be a point in triangle ABC. G is a centroid of triangle ABC if and only if one of the followings. The first one, okay, let's just look at it. A, B, C. Okay, so the area of triangle GBC equals to area of triangle GCA equals to area of triangle GAB equals to 1/3 of triangle ABC. Once G is a centroid, it's obvious, right? Because if we can extend AG to D, right? D is on BC, then we know that AG to GD is 2 to 1, which means the area of triangle BGD is half of the area of triangle ABG. And the area of triangle GDC is half of the area of triangle GAC, right? Which means the area of triangle BGC is 1/3 of the area of triangle ABC. Similarly for other two sides. So if G is a centroid, it's easy to prove. And what about if we already know that the area of triangle GBC equals to area of triangle GCA equals to area of triangle GAB? Well, if these three are equal, then they all definitely equals to 1/3 of triangle ABC, right? So this is a redundant problem set, but let's just say if we have these three to be equal, can we prove that G is a centroid? Right, so let's just think about that triangle GA, the area of triangle GAB equals to the area of triangle GAC. They have the same edge AG, which means the height from B to AG equals to the height from C to AG, which eventually means that BD equals to DC. Means that AG is a median of triangle ABC. Similarly, for the BG and CG, then we know that G is a centroid, right? Okay, the first one is simple, and the second one, D, E, F are projection from G to BC, CA, AB. A, B, C. So we have the centroid here. G, D, E, F, right? When GD times GE times GF has a maximum, then G would be the centroid of triangle ABC. So let's just say BC, the length of BC is A, the length of AC is B, the length of AB is C, and GD is X, GE is Y, GF is Z, right? So we know that half of AX plus half of BY plus half of CZ equals to the area of triangle ABC, right? Which means AX plus BY plus CZ is a constant. It equals to triangle, twice of the triangle area, right? And we already know that AX plus BY plus CZ so this is a constant, right? So we have the what's the term for the inequity? I need to refresh myself the English term. But we actually can directly use it, right? So we know that AX times, so because this is a constant, AX times BY times CZ would be smaller or equal to that AX plus BY plus CZ divided by 3 and to the power 3, right? That's a inequality equation we have. So means x, y, z smaller or equals to this is this one, right? Times 1 by ABC. And this is valid only, I mean the AX times BY times CZ equals to this one only AX equals to BY equals to CZ, right? And if AX equals to BY equals to CZ, that means the area of triangle GBC equals to area of triangle GCA equals to area of triangle GAB, right? Which from the first problem proves that we know that G is a centroid of triangle ABC. So once AX, once X, Y, Z has a maximum value, we know that G is a centroid, right? You can see this is kind of similar to what we proved before in center and circumcenter, right? Just different form. Okay, let's see next one. The next property is 3. So line AG, BG, CG intersect edges on DEF respectively. And okay, let's just draw it. I'll just use this one on DEF respectively. And we know that the area of triangle AFG, this one, equals to the area of triangle BDG, this one, equals to the area of triangle CEG, this one. Right, so basically when these 3 are equal, we want to prove that G is a centroid. Let's just consider about when G is centroid, whether they are equal. It's obvious these 3 are all 1/6 of the area of triangle ABC, right? So when these 3, the area of these 3 triangles are equal, we want to prove that G is a centroid. Let's just assume the area is 1, 1, 1 here, right? And the area of BFG would be X. The area of CDG would be Y. The area of AEG would be Z, right? Because this is kind of symmetrical, so we can have the following assumptions that X is larger or equals to Y and larger or equals to Z, right? Once X, Y, Z are all equal, then we directly proved, right? Because if these 3 are all equal, that means the area of triangle ABG equals to the area of triangle BCG equals to the area of triangle ACG. Then we know that G is a centroid, right? So let's see what are the conditions we may have here. So x larger than y equals to z, x equals to y larger than z, right? Or x larger than y larger than z, right? And we already say that if x equals to y equals to z, we know that G is centroid, right? So we want to check on other three conditions. For this figure, we know that the area BD to DC equals to the area of triangle BDG to the area of triangle CDG, which equals to 1, 2, y, and also equals to the area of triangle ABG to the area of triangle ACG, right? So it equals to 1 plus x to 1 plus z, right? That's BD to DC. And what about CE to EA? CE to EA equals to 1 to z, right? Also equals to 1 plus y to 1 plus x. What about AF to FB? AF to FB equals to 1 to x, which equals to 1 plus z to 1 plus y. Right? And let's think about the case that x larger than y, but y equals to z. So if y equals to z, which means x equals to 1, right? And if x equals to 1, so let's see, y equals to z. So we got x equals to 1, right? And because y equals to z, so 1 over y equals to 1 over z, right? That means 1 plus x 2, or let's just say 2, 1 plus z equals to 1 plus z, right? Because this y equals to z, so we replace it, right? 2, 2, which means 1 plus z equals to 2, which means z equals to 1, and which means equals to y, right? So all x, y, z are equal, right? So this condition cannot happen that x larger than y equals to z, because once y equals to z, we eventually got x also equals to y equals to z, right? So this cannot happen. And similar for this case, if x equals to y, x equals to y, that means this one, then z equals to 1, right? And when x equals to y, these two terms are equal. And because z already equals to 1, so we know that y or x are also equals to 1. So this case is not going to happen. And what about the case x larger than y larger than z? Because x is larger than y larger than z, which means 1 over x is smaller than 1 over y smaller than 1 over z, right? And look at this one. What is actually this one? What is y? Y is 1 plus x to 1 plus z, and we want to. So this should be valid if x larger than y larger than z, right? Then this should be valid that 1 plus x to 1 plus z, which is 1 over y, should be smaller than 1 plus y to 1 plus x, right? And we already know that 1 plus x to 1 plus z should be larger than 1, right? And because x is larger than z, so this is larger than 1, and 1 plus y to 1 plus x should be smaller than 1. This is wrong, right? This cannot, this is not valid, it's not wrong, this is not valid, so which means this case is not valid, which means that only this case can be exist that x equals to y equals to z, right? If the triangle area AFG of the triangle area BDG and the triangle area CEG are equal, right? That means the rest of 3 parts are also equal. Once they are equal, they all equals to 1, and which means G is a centroid. Okay, let's see next. Maybe, yeah. A line passing through G and intersects AB on P, intersects AC on Q. This one. So let's just draw it here. A, B, C. Let's consider the centroid here, right? A, D, B, E, C, F. And we have a line passing through the centroid. Intersects AB on P, intersects AC on Q. We want to prove that AB to AP plus AC to AQ equals to 3. So, because we already know that the ratio of AG to GD, right? And we want to find the ratio of AB to BP and the ratio of AC to AQ, right? So, we can, from B and C, just do a parallel line to the AD, right? So let's call this point as M, this point as N. Right? We do parallel line from BC, from point B and point C, do the parallel line of AD and meet the line PQ on M and N, right? What we can get here, that AB, so AB to AP, AB to AP equals to MB plus AG to AG, right? And AC to AQ, AC to AQ equals to, oh, so because this one is these 3 are in parallel, right? So I forgot to say that because this is too straightforward, that triangle A, not F, let's call AP, right? Triangle APG is similar to triangle BPM, right? And also triangle AQG is similar to triangle CQN, right? So that's why we have it here. That's AB to AP equals to AB to AP equals to MP plus AG to AG. And similar here, AC to AQ equals to CN plus AG to AG, which means AB to AP plus AC to AQ equals 2. So that's 2 plus MB plus CN to AG, right? Which means we want to find the relation between CN, MB, and AG, right? Because MB is in parallel with CN, so MBCN is a trapezoid, right? And DG see here, so CNB, CNBM, right? We have D here, G here, right? We know that D is a midpoint of CB G is a midpoint of Mn, right? Because DG is in parallel with BM in parallel with Cn, and because D is a midpoint of CB, so G is a midpoint of Mn, and which leads us that Cn plus Bm equals to twice of dg, right? That's a property of the trapezoid, which means this one is twice of dg, right? Twice of dg, so 2dg to ag. And we already know that 2ag to dg equals to 2 to 1. So 2dg, that is ag, so this equals to 3. Okay, we just prove that if G is centroid, that this equation is valid. Now let's say this is valid. How can we prove that G is a centroid, right? See, if this is valid, if AB to AP plus AC to AQ equals to 3 is valid, we can still do this, right? We can still do this. We just need to prove that now the PQ, the line PQ is passing through the centroid, right? So think about this way. Let me draw it here. Right, we just have a line here, and we can connect. We can draw the median here, right? Now let's call this another name. So A, B, C, P, Q, right? And we still do the parallel line as M here, N here, right? So let's call it's still the median, right? And the median, this median intersects PQ on another point. Let's call it H, right? So we already know that AB to AP plus AC to AQ equals 2 plus MB plus CN to AH, right? This is still valid, right? This is still valid. And we know that this equals to 3, which means MB plus CN equals to AH, right? And because MB plus CN, that is twice of DH, so we got 2DH equals to AH. And because AD is a median, and we have the H point that satisfy AH to DH equals to 2 to 1, that means H is centroid, right? That means H is a centroid. Okay, let's see the next one. Now we want to prove that BC squared plus 3GA squared equals to CA squared plus 3GB squared equals to AB squared plus 3GC squared. Right, that's very interesting one. Let's see whether it's true. A, B, C. This is G, right? So, again, AD squared equals 2. What is AD squared? AD squared is 1 by 2 AB squared plus AC squared minus quarter of BC squared. Right. So AG squared is 4 by 9 AD squared. Right. That means BC squared plus 3GA squared equals 2. BC squared plus 4 by 3. 4 by 3 AD squared. AD squared is 1 by 2 AB squared plus AC squared minus 1 by 4 BC squared. Right? And it equals to BC squared plus 2 by 3 AB squared plus AC squared minus 1/3 of BC squared, which equals to 2 by 3 AB squared plus AC squared plus BC squared. Right? Similarly, for the CA squared plus 3GB squared, we can still get this one. We can see this is symmetrical, right? Symmetrical thing. So the question is that how can we prove if this one is valid? How can we prove that G is centroid? Right. Okay, now let's just think about BC squared plus 3GA squared equals to CA squared plus 3GB squared equals to AB squared plus 3GC squared. Excuse me. So, for this one, let's consider G is a variable. G is a point that we can move around, right? We have BC squared. Oh, let's just change the name of the this point. That would be easier. So let's consider that G is a centroid, right? We already know this is valid. We just proved that. Now let's consider about another point that's still satisfying this condition. Let's call H, right? So BC squared plus 3HA squared equals 2. CA squared plus 3HB squared equals 2. AB squared plus 3HC squared. Okay? Now look at the first two terms. We know that BC squared minus CA squared equals 2. 3HA squared plus 3HB squared minus 3HA squared, right? And in a triangle, we know that HB squared minus HA squared equals to 1/3 of BC squared minus CA squared, right? So BC squared minus CA squared, that is a constant. So 1/3 of it is still a constant. Excuse me. So BC squared minus CA squared, that is still a constant, right? 1/3 of it is still a constant, which means we consider H as a point that move around on this plane, right? Which means we want to find where is that H, right? Think about H, B, H, A. Because HB squared minus HA squared, let's just find the projection from H to AB. Let's call it T, right? So hb squared minus ha squared equals to hb squared minus ht squared minus ha squared minus ht squared, right? That is equal, which means bt squared minus at squared, right? And we already know that G, the centroid, is a valid point that satisfies this equation, right? Which means that if we just draw the projection from G to the AB, we find the T, right? Means all the H should be on the perpendicular line from centroid G to AB, right? G should be on this point. So if we do the perpendicular line from G to AB, and H should be on this line to satisfy the first two, right? Similarly, if we do G from we do the perpendicular line from G to AC, then we know that BA, BC, right? BC and BA. So we know that all the H satisfy these two should be on the perpendicular line from G to AC, and also for these two, the H should be on the line from on the perpendicular line from G to BC, which means we are looking for a point that is on the perpendicular line from G to AB, AC, and BC at the same time, and which means that G is a point we're looking for, right? Because these three lines has an intersection point on G, right? The concurrent on G. So G is H we're looking for, right? That means if these three equations or these three terms are equal, then G is a centroid. Okay, let's see the next property. Property 5. The distance of centroid of triangle to any line L equals to 1/3 of the sum of the distance of three vertices to the same line. Okay, so we have the centroid here, A, B, C, G, right? And this is a line we're looking at. So the distance from G to this line, L, let's call it D, right? And the distance from A, B, C to the line L, we call it DA, DC, and DB, respectively. We want to find the relation between D and DA, DB, DC, right? So we just draw the E to here. Because all of these distance lines, they are all in parallel. So let's call this as D, E. So we know that D, E is a midpoint of AC, so DE equals to half of DA plus DC, right? DE equals to half of DA plus DC. And because BG to GE equals 2, see, BG to GE equals 2 to 1. That means this distance to this distance is 2 to 1, right? So we can just think about draw another point, find the midpoint of BG here. So we know this distance, because this is an auxiliary line, so we call it AUX, right? Then we know that DB plus D equals 2 twice of DAUX. And DAUX plus auxiliary plus this one DE equals 2 twice of D, right? Which means DB plus D equals 2 twice of 2D minus DE, right? So DB plus 2DE equals to 3D, which means D equals to 1/3 of DB plus 2DE equals to 1/3 of DB plus, what is D? D is this one, DA plus DC, right? That is saying the distance from the centroid to any line is 1/3 of summation of the distance of 3 vertices to the same line. Okay, that's property 5. And property 6. Let G be the centroid of triangle ABC. If AG squared plus BG squared equals to CG squared, the median AD and BE are perpendicular to each other. So let's just think about the median. Okay, looks like this. We want it to be perpendicular. Right, roughly say it's correct. So you can see A, D, B, E, C, right? This is G. So we know that AG squared plus BG squared equals to CG squared, right? And we want to prove that AD is perpendicular with BE. So AG squared plus BG squared equals to CG squared. And we already know that CG squared is 4 times of GF squared, right? So which means we got AG squared plus BG squared equals to 4 times of GF squared, right? So this is a median. This is a median. We know that AG squared plus BG squared equals to CG squared, and CG is twice of FG, so that is 4GF squared. The question is, how can we prove that AG squared plus BG squared? Because if AD is perpendicular with BE, then AG squared plus BG squared equals to AB squared, right? So how can we prove this? Look at this. AG squared plus BG squared equals to 4 gf squared. And we already know that gf squared equals to half of ag squared plus bg squared minus 124 ab squared, right? That's from the Stuart's theorem. So 4gf squared equals to 2 of ag squared plus bg squared minus ab squared, right? And we know this equals to ag squared plus bg squared, which means ag squared plus bg squared equals to ab squared, which means ag is perpendicular with bg, right? This is 90 degrees. And for the case that if median AD and BE are perpendicular to each other, then we have this form. So if AD and BE are perpendicular to each other, we already know that AG squared plus BG squared equals to AB squared. And we know that FG is a median in triangle AGB, right? So FG is half of AB, which means GC equals to AB, right? GC equals to AB if this is 90 degrees, and we know that AG squared plus BG squared equals to AB squared, right? Because this is 90 degrees, so AG squared plus BG squared equals to GC squared. That's the second case. Okay, that's a property of the centroid we just introduced. But unfortunately, I actually didn't find a lot of interesting problems that just focus on the centroid only. I found one, but not too many. And some of the problems are actually need to consider the centroid and the other centers, such as in-center, circumcenter, or orthocenter. That makes me kind of want to postdate. Let's just wait until we discuss the relationship between these centers. Okay. For this video, we introduce several properties. I think some of them are very useful in solving the problems that relates to the centroid. I hope you like this video. See you in next one. Thank you.